capacitor of capacitance
Okay.
10 microfarad, and this is 10 volts.
Yes, sir.
So initially we will solve problems fully charged. Later on we will see charging and discharging. Okay.
Yes, sir.
For charging and discharging we need resistance. Therefore, we will do that in current electricity.
Yes, sir.
Okay. So what are the charges placed? Is 10 into 10 to the power minus 6.
Into 10.
Yeah, this is capacitance is 10 microfarad into 10.
Why microfarad?
I mean, micro is 10 to the power minus 6. That is nothing to do with the unit. Farad is the unit of capacitance. I wrote it as coulomb.
Yes, sir.
Coulomb is what we will get now.
Okay, yes, sir.
Okay, so we can write it as 100 microcoulomb or 10 to the power minus 4 coulomb is the total charge placed on the. Okay.
Yes, sir. Sir, Faraday was that person in the magnetism, right?
Faraday is what?
There was one person in magnetism. He was.
Okay.
I'm asking, sir. I don't.
Okay. I haven't learned magnetism yet. Anyways, that is Faraday's laws is what you're saying.
I intend to it somewhere that also.
If the area of each plate, is 1 millimeter square, if the area of each plate is 1 millimeter square, then find the electric field between the plates. Okay. Now remember, this is the positive terminal, this is the negative terminal. That is the sign convention. Okay.
Yes, sir.
So as we have discussed earlier, the positive terminal will be having positive charges and the negative terminal side will be having negative charges.
Yes, sir.
Obviously, I'm showing the charges here and there, but the left plate will have positive charges on the right side of it, and the right plate will have negative charges on the left side of it. Will be on towards each other. The
Yes,
charges
sir.
will be towards each other, facing each other. But because there is no space, I am drawing it outside. Okay.
Yes, sir.
So if area is 1 millimeter square, what is the electric field between them? So what is exactly happening over here is I have two plates, and of course when we say capacitor, that means very close to each other. Okay. And if suppose I have plus sigma charges on this plate, positive charges, and this is negative charges. If I have plus sigma and minus sigma, what is the electric field in terms of sigma between the plates?
Sigma by epsilon naught.
Sigma by epsilon naught. So therefore, the electric field is nothing but
Charge upon yes, sir.
so 10 to the power minus 4 coulomb. What is area? Millimeter square. So that is in terms of meters, it is 10 to the power minus 6
Yes, sir. No, 5.
because it is 10 to the power minus 3 meters whole square.
Yes, sir.
Millimeter.
Yes, sir.
So 10 to the power minus 6 into epsilon naught is 8.85 into 10 to the power minus 12.
Yes, sir.
Right? So you can
It is 8.8. Okay, whatever. I thought that was 3. Sorry.
8.85. So using calculator we can figure out, right? Newton per coulomb. Just check how much are we getting.
8.86 into 10 power max. Sir,
My,
I thought you wrote it as 3.
that's fine. How much are we getting?
I saw.
Somewhere around
Sir,
0.112,
0.1. Yes, sir.
10 to the power 14 Newton per coulomb.
Yes, sir. Yes.
Okay.
Mm.
Now, we do know that electric field is, we do know that electric field is nothing but minus dV by dr, right?
Yes, sir.
If the distance between the plates is small d, if the distance between these parallel plates is small d, then can I say it is nothing but electric field? I'm talking of magnitude is potential difference divided by the distance d.
But we need change in the distance, right?
There is nothing called change in the distance. It is distance between the plates. We are not changing the distance between plates. This
Okay,
is
yes, sir.
this is the distance between plates, small d.
It's representing like the small distance. Okay.
Yeah, but distance between plates is usually given as small d.
Yes, sir.
Okay. Now, what I am trying to say is, can I get the distance between the plates from here? So basically, what we have is electric field is potential upon d. I don't need any negative sign, positive sign stories over here because it really doesn't matter. I'm comparing the magnitudes because I just need the distance between the plates, right? Positive, negative is not a problem for me. So electric field, I got it over here. How will I
Yes,
get distance d?
sir. They already gave potential difference.
But
That
will the
is,
potential difference across the plates be the same as that of the potential difference across the capacitor? Will the potential difference across the plates of the capacitor be the same as that of the battery? So here you have battery having 10 volts. Down you have capacitor. Will the potential difference across the capacitor also be 10 volts? And if yes, why? And if no, why?
their electric field is constant.
I told you that day we chose some 2 points, 4 points you chose. You wrote that English all by yourself in your class notes. You chose A, B, C, D, and the potential. So the points that you chose were basically like this. This is A, this is B. Take this as C and this is D. You said the potential at A is same as potential at B and potential at D is same as potential at C. This happens when the capacitor is fully charged.
Yes, sir.
Only when the potential at A is same as potential at B, that is the battery's positive terminal potential, which will match with the capacitor's positive plate. Only then will the charges stop flowing through this conductor.
Yes, sir.
Otherwise, if VA is not equal to VB, then charges will continue to flow till VA is equal to VB.
Yes, sir.
The potential at B is nothing but the potential of the left plate of the capacitor, and it depends on the number of charges on the plate of the capacitor.
Yes, sir.
As the charges keep increasing, the potential at B also keeps increasing. It can only increase till the value of VA. It cannot exceed the value of VA by itself.
Yes, sir.
So the charges will accumulate on the plates of the capacitor till the potential at B is same as A and potential at C is same as D. Therefore, the potential difference across the capacitor will also be 10 volts for fully charged condition. For fully charged condition, the potential difference across capacitor is also 10 volts. Do you have any doubt over here?
No, sir.
Is it clear?
Yes, sir.
So therefore the distance we can find, distance D between the plates is nothing but potential difference is 10 volts divided by electric field is 0.112 into 10 to the power 14. Or you can keep it as like this only and substitute, then also we will get. Yeah?
Yes, sir. There are the potentials like after fully charged, we are taking on the plate, on the positive plate and on the negative plate.
Hmm? What?
After they get fully charged, we are
Hmm.
taking on the positive plate and on the negative plate.
The charges are accumulated. What is your point?
Now we are taking potentials at that place, right?
Potentials at that place.
Like where exactly the capacitor, I mean the plate of the capacitor is there.
Are you asking or are you telling me?
I'm asking, sir.
Where are we taking the potential difference?
They're like on the plates, right?
Yes, VB is nothing but on the plate only. VB is nothing but on the plate only. Because we have shown positive charges over here, I will show B there only. So we can't read what we are writing. VB point is same as the left plate. VC point is the same as the right plate.
Yes, sir.
Similarly, VA is not different from the battery's left side. VA is same as the left side of the battery and VD is same as the right side of the battery. We are taking potential difference across the capacitor. See, another way of finding distance D is the capacitance itself is epsilon naught A by D, right? We did this
Yes, sir.
parallel plate capacitor. Capacitance is given, area is given, epsilon naught is given. From here, both we will get the same value. Or we can say both are basically the same.
Yes, sir.
Xerox.
The distance is 10 by 16. It's 2. The distance,
If we substitute area is 10 power minus 6. Epsilon naught is 8.85 into 10 to the power minus 12 divided by capacitance is again 10 to the power minus 5. So we will have 8.85 into 10 to the power minus
yes,
13
sir.
meters.
Yes,
So that's the reason we say that the distance between the plates is very small. That means plates are very close to each other.
yes, sir.
So this time you solve everything.
Yes, sir.
So we have a capacitor, a battery. The battery is 100 volts. Capacitance is 300 microfarad. The distance between the plates is 1 micrometer. So find the charge on each plate, the electric field between the plates, and the area of each plate. Q is equal to CV, right?
Yes, sir.
300 into 10 power minus 6 into
10 power minus.
100, which is 3 into 10 to the power minus 2 coulomb.
Yes, sir.
Area we can get by capacitance is equal to epsilon naught A by D. So 300 into 10 to the power minus 6 is equal to epsilon naught area divided by 1 into 10 to the power minus.
Yes.
So we'll have area is 300 upon epsilon naught into 10 to the power minus 12
Yes, sir.
meters. Last is electric field is basically sigma by epsilon naught.
Minus dV.
Or we can also get electric field as potential upon D.
Yes, sir.
Either way, right?
Yes, sir.
100 volts divided by 10 power minus 6.
Yes, sir.
We will get it as,
But won't we have minus?
why do we need minus or plus when we are talking of electric field? I mean, there is no, it is from positive to negative, right?
Okay, yes, sir. We are anyway going from high potential to low.
Electric field is from positive plates to negative plates. This I am taking as positive plate and this I am taking as negative plate because this is positive terminal and that is negative terminal.
Yes, sir.
Okay. So we have three capacitors, 1 microfarad, 2 microfarad, and 3 microfarad placed in series. Find the equivalent capacitance of these three capacitors. Similarly, if the same three capacitors are placed in parallel, 1 microfarad, 2 microfarad, and 3 microfarad. Now find the C equivalent. I'll write this as C dash equivalent. Find the equivalent capacitance of the series and parallel combinations of three capacitors of 1 microfarad, 2 microfarad, 3 microfarad.
The first one will be 6.
Because
Sorry. It will be 1 by 1 plus
correct.
by 2 plus 1.
So for series we have 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Therefore it is 1 plus 1 by 2 plus 1 by 3, which is 3 plus 2 plus 11. 6 plus 3 plus 2, 11 upon 6. So C equivalent is equal to 6 upon 11 microfarad.
Yes, sir.
For parallel, C equivalent is C1 plus C2 plus C3. Therefore, it is simply 6 microfarad.
Yes, sir.
Suppose I have a combination in this way. These two capacitors are in parallel and this combination is in series with this fellow. It's always important to see where the terminals are given, that is A and B. Okay,
Yes.
so three capacitors of capacitance C, C and C are shown in figure. Find the C effective, C equivalent across A and B. The terminals
1
giving
by 2C plus 1 by C.
1 by 2C plus 1 by C. Because these two are in parallel, you are saying these two together will be 2C and this is C. So in
Yes.
series, we will have half plus 1, reverse of it. Fine, good. So C equivalent is equal to 1 upon 1 by 2C plus 1 by C. Right?
Yes, sir.
How much will we get this as? 3 by 2 comes 2 by 3, 2C upon 3.
There again by 1 upon 1 by 2C directly 1 by 2C
In
plus 1 by
series, we will have 1 by C equivalent is equal to 1 by C1 plus 1.
Yes, sir. Yes, sir. And
So what I usually will remember is reverse of reverse. So I'll have to, so half of it my brain will do anyways. I have to just add the 1 by in the end to get C equivalent.
yes, sir.
So let's take fifth question. You solve this one. 4 capacitors are placed like this. Each has a capacitance C. Terminals are shown over here. Find the C equivalent for this combination.
There it will be C.
Because half and half is 1. These two as a combination we will have as half C by 2. These two as a combination we will have C by 2. And half in parallel, I will get this as C. Good. Now we will solve the complicated things from HCV. Let us jump into this fellow. Okay. So I have a combination shown in figure 1 microcoulomb, 1 microcoulomb, 1 microfarad, 1 microfarad, and 1 microfarad. The capacitance of each capacitor is 1 microfarad. The potential difference is 100 volts. Find the charges on the capacitor shown in the figure. Find the charges on the plates of the capacitor, of this capacitor.
Basically, we need to see how much potential is going to reach the
Yes,
terminals.
I will solve it. Okay. Just close the book. Close your book and focus. I will solve it.
Yes, sir.
So what we are saying is that we have 2 in series, 2 in parallel, and that combination is in series with the third one. So I can solve it in this way, saying that this combination looks something like this, where the capacitance over here is 2 microfarad, right?
Yes, sir.
Here is 1 microfarad, and this is 100 volts. And this combination looks like something like this. We just did this. It is 2 by 3. 1 divided by 1 by 2
Yes.
plus 1 is
Yes,
2
sir.
by 3. So I have 2 by 3 microfarad and 100 volt attached to it. So using this, I will have charge is equal to Q is equal to C into V, which is 2 by 3 into 10 to the power minus 6 to 100 volts. So we can say 2 by 3 into 10 to the power minus 6, minus 4, right? Coulomb.
Yes, sir.
Or we can, for simplification, we can write 200 by 3 microcoulomb. That is also fine. Correct?
Yes, sir.
Now, using this information, I got 200 by 3 microcoulomb. But about series, charge is same. That means that 200 by 3 microcoulomb is on both the capacitor, correct?
Yes, sir.
Because in series, charge is same, correct?
Yes, sir.
In series, charge is. That means on this particular capacitor, I have 2 by 3 microcoulomb. So if I say this point is P and this point is Q, we can say potential minus P minus potential at Q. Okay, because Q is equal to CV, I can write V is equal to Q upon C.
Yes, sir.
Q upon C is nothing but 200 by 3 microcoulomb divided by capacitance is 2 microfarad.
Yes, sir.
So the potential difference I can write is 100 by 3
Yes, sir.
volts.
Now that potential is constant.
Now here, that means here I have 100 by 3 volts as my potential difference, and capacitance is this. So therefore I can get the charge on the capacitor. Let's say this is A, B and C. So we want charge on the capacitor C plate, correct?
Yes, sir.
So charge on C is equal to Q is equal to C into V. Capacitance is 1 microfarad and potential difference is 100 by 3. So I can write this as 100 by 3 microcoulomb. Is this clear?
Yes, sir.
I will explain this again. Once the combination is given, I can solve my combination to make it look simpler and easier, and further solve it, and eventually my C effective of this entire combination looks like this. From here I am getting what is the charge present on that particular C effective, which is 200 by 3, which I know will be the same over here because in series Q is same. That means each capacitor, that is 2 microfarad, will also have 200 by 3. Now I am finding potential difference across this capacitor, which is 100 by 3 volts, which I am using over here because these 2 points will also be P and Q. Potential difference in parallel, potential difference is same.
Yes, sir.
Therefore, I am getting the potential difference as 100 by 3 volts and this one. Okay.
Yes, sir.
Method 2. I told you that everywhere, anywhere, in any place, all over the country, know this thing. Hello everyone. Welcome to Viratious Academy. My name is Anil Kumar. I am an alumni of IIT Bombay. I have done my BTech from Mechanical Engineering. I have been teaching physics for the past decade for JEE Mains, JEE Advanced, NEET UG, and other competitive exams. If you're interested to attend my sessions, please find the contact details in the description below. Let's get started with this lecture. Enjoy the video. I was saying that anybody all over the country will be able to solve this. That is not a problem at all.
Yes, sir.
Okay, so how do we solve it in method 2? More or less, we are doing the same thing, but we are using the extra part which I discussed in series and parallel capacitors. So since it is 1 microfarad everywhere, let us take the capacitance as C everywhere and potential as V, which is 100 volts basically. Or let's take it as V1, let's say. Now,
Why we? Oh, sir, same question, right?
I am solving the same question.
Yes, sir.
I am taking the capacitance as C everywhere, and I am taking the battery's potential difference as V1. We will substitute the values later.
Okay, sir.
Now, parallel we have 2. So this anyways I have to do. This is 2C and this is 1.
Yes, sir.
Okay. So we can also look at it this way. That question is basically I need to find what is the charge on this plate, right?
Yes, sir.
So let the potential difference across this is V dash. So how will I get charge? I will get C into V dash. Charge that on that capacitor is C into V dash. Capacitance is already given. I want to find potential difference. If I want to find potential difference, that means I have to find potential difference across the points P and Q. This is P, this is Q. I just need Vp minus Vq. So I'll have to come to this figure. That means the battery is given and I have 2 capacitors. And it is easy also for parallel. I can write 2C and C. This is V1. Now in series, Q is same, right?
Yes, sir.
Or we can say Q is equal to constant, therefore V is equal to constant, therefore V is inversely proportional to C, right? For series, can I write V is inversely proportional to capacitance?
Yes, sir.
That means V1 is to V2 is equal to C2 is to C1. This is what we had discussed,
Yes, sir.
right?
Yes, sir.
So if this is 1 and this is 2, V1 is to V2 is nothing but C2 is to C1.
So it will be 1:2.
1 is to 2. That means the potential difference across delta V across PQ is 1/3 of total voltage V1.
I want.
Because it is 1 is to 2.
Yes, sir.
1 is to 2 means I am getting 1/3 of
Yes, sir.
V1. That means I know V dash is equal to 100 by 3 volts. 1/3 of V1. V1 is 100 volts, right?
Yes, sir.
So now I can get capacitance as charge as capacitance is 1 microfarad 10 to the power minus 6 into 100 by 3. Anyways, I can write it as 100 by 3 microcoulomb. For
Yes,
objective questions, solving this way is faster because you will not write these many things over here. Right now, I am writing it over here only to explain it to you, but you will not put so many things on paper. You will do most of the things in your head.
Yes, sir.
All you need to get is the potential difference across. This is one third of the total. So 100 by 3. And you will directly write from here only when you're solving.
Yes, sir.
0. Hi guys. I hope you enjoyed the session. If you think this video was useful, don't forget to like, share, and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.